In this session, we will do some problems based on vector addition. So there are two types of vector addition. One is the triangle law of vector addition and another is the parallelogram law of vector addition. What is triangle law of vector addition? Suppose if I have two vectors a bar and b bar. So I have to add these two vectors. Now what I will do is I will translate this vector b bar such that its tail lies on the head of the vector a bar. Then the resultant vector will be the one which starts from tail of the first vector, that is a bar vector, and end at the head of the second vector, that is b bar vector. So this is the resultant addition. What if I have to add the two vectors which originate from the same point, like this? So let's say this is vector a bar and this is b bar. So the resultant of this vector is somewhat like this, which is given by the parallelogram formed by these vectors a bar and b bar. Let me construct this parallelogram. So this is a bar again and b bar is this vector. So this is the parallelogram. So these two vectors b bar are parallel and a bar, these two vectors are parallel because opposite sides of the parallelogram are equal and parallel to each other. And this is the vector, suppose c bar. So let's say the angle between the vectors a bar and b bar is theta, and let's say the angle the c bar makes with the angle with the vector a bar is alpha. So the magnitude of the vector c is given as square root of a square plus 2ab cos theta plus b square, and the direction of the vector c bar, that is alpha, is given as tan inverse of b sin theta upon a plus b cos theta. So a and b in these two are magnitudes of the vector a bar and b bar. So I am not deriving this in this session, that is the magnitude of this vector c, that is the resultant vector, and the direction of this vector, but I have already shown the derivation in my previous video section. Now let's talk about this question in detail. The problem states that there are two forces, 4 Newton and 3 Newton, and they are acting at an angle 120 degree between them. So let's say this is the 4 Newton force and this is 3 Newton force. So the angle between these two vectors or forces is 120 degree. So this is the force F1, suppose, and this is the force F2. So the resultant vector's magnitude will be given by, let's say the resultant force is F, so it is square root of F1 square plus F2 square plus 2F1 F2 cos theta. So this becomes square root of F1 square is 60, F2 square is 9 plus 2 into 4 into 3 into cos theta. So what is theta? Theta is 120 degree. I can write cos of 120 degree as cos of 180 degree minus 60 degree. So this becomes square root of 16 plus 9 is 25 plus 2 into 4 is 8 and 8 into 3 is 24 into cos of 180 minus 60 will be minus cos of 60. So this becomes square root of 25 minus 24 times cos of 60. Cos of 60 is half, so this becomes square root of 25 minus 24 by 2. So this becomes square root of 25 minus 12, which is nothing but square root of 13. So square root of 13 Newton is the resultant force F. Now they have also asked for the direction of the resultant vector. So let's calculate tan alpha. So tan alpha is equal to b sin theta upon a plus b cos theta. What is b here? B is F2 and a is F1. So this becomes F2 sin theta, that is 3 into sine of 120 degree divided by F1 plus F2 cos theta. So F1 is 4 plus F2 is 3 and cos of 120 degree. So sine of 120 degree can be written as sine of 180 degree minus 60 degree divided by 4 minus 3 by 2. So I have written cos of 120 degree directly as minus 1 by 2 because we have already done the calculation here. So this becomes 3 into sine of 180 minus 60 is nothing but sine of 60 divided by 8. So 2 into 4 is 8. 8 minus 3 divided by 2. So this becomes 3 into root 3 by 2 divided by 5 by 2. So this 2 gets cancelled. So this becomes 3 root 3 divided by 5. This is my tan alpha. So what is alpha then? Alpha is nothing but tan inverse of 3 root 3 by 5. I had already done the calculation of tan inverse of this using a calculator. So this is about 46 degree. So the resultant vector is at an angle 46 degree with respect to the force F1 and with the magnitude square root of 13 Newton. Let's talk about next question. So the two forces 3 Newton and 4 Newton are acting on a body. So what are the maximum and minimum forces? The two forces, let's say, are 4 Newton like this, and let's say some angle between these two vectors is there, 3 Newton. We don't know this angle, let's suppose. So the 4 Newton is F1 suppose, and F2 is 3 Newton. So what is the maximum and minimum force? So the maximum and minimum force can be calculated using the formula we know, that F is equal to square root of F1 square plus F2 square plus 2F1 F2 cos theta. So when this resultant force F will be maximum, we know that F1 and F2 is already fixed, that is 4 and 3, so we cannot vary this. But the only term that can be varied is this term, because it contains cos theta, and cos theta the angle between these two vectors is variable. So when cos theta is maximum, this term will get maximum, and thus the resultant force will be maximum. So when the cos theta is maximum, or what is the maximum value of cos theta? So maximum value of cos theta is nothing but 1, and that happens when theta max, that is the angle between these two vectors, will be 0. So this becomes square root of F1 square plus F2 square plus 2F1 F2. So this becomes F1 plus F2 whole square and the square root of that. So this becomes F1 plus F2. So this becomes 4 plus 3 Newton. 4 Newton plus 3 Newton, which is 7 Newton. 7 Newton is the maximum force. That is when the two forces are acting in the same direction, you will get the maximum force. So when the two forces are acting in the same direction, the result will obviously be the arithmetic addition of 4 Newton and 3 Newton force. This will be 7 Newton. So we could have done directly with the intuition, but I wanted to show you from this equation. So when the forces will be minimum, obviously the forces will be minimum when the 4 Newton force is acting 180 degree opposite to that of force 3 Newton. So we can see it also from here. Let's say F is F1 square plus F2 square plus 2F1 F2 cos of theta. So this term will be minimum when cos theta is minimum. The cos theta minimum value is -1, and theta minimum then becomes 180 degree. So this becomes square root of F1 square plus F2 square minus 2F1 F2, because cos of 180 degree is -1. Let me write subscript minimum here, because we are calculating it for the minimum force, and let's say it is maximum here. So this is F1 minus F2 whole square in the square root of that. So this becomes F1 minus F2. So the minimum force is 4 Newton minus 3 Newton, which is 1 Newton. So this is the minimum force. So let's talk about next question. The square of the magnitude of resultant of two vectors is the sum of the squares of the magnitudes of these two vectors. Let's say the two vectors are A bar and B bar, and let's say the resultant vector is C bar. So it has stated it is stated that c square is a square plus b square. And we know that c square is a square plus 2ab cos theta plus b square from the parallelogram law of vector addition. Let's substitute it here. So this becomes a square plus 2ab cos theta plus b square is equal to a square plus b square. So this a square gets cancelled and b square also gets cancelled. So we get 2ab cos theta is equal to 0. Now a and b are fixed quantities. So cos theta will be 0. So cos theta is equal to 0 and theta is equal to 90 degree. So the angle between the two vectors is 90 degree.